Have you ever wondered what the world is made of? I mean, really, really made of? If you zoom in past your skin, past the cells, past the molecules, past the tiny little atoms, you enter a place so strange and so cool, it sounds like science fiction. This place is the quantum realm. The science is called quantum physics. It's one of my favorite topics because it's full of mind-bending surprises. It's the set of rules that governs the universe on the smallest scale. And they are nothing like our everyday rules. It's a world where things can be in multiple places at once and can be connected over vast distances. How cool is that? In our big world, a soccer ball is either here or it's over there. It can't be in two places at the same time, right? But in the quantum world, electrons can do exactly that. It's like they haven't made up their mind until we look at them. This idea is called superposition. Scientists have explored this hidden universe for over a century, and every discovery opens new possibilities. Quantum physics powers the tech we use daily, from computers and lasers to MRI machines and solar panels. It's not just a textbook idea, it's already shaping our lives in countless ways. The science of the super small is having a super big impact. To see why the new discoveries are exciting, let's zoom in. 1,000,000 times smaller than a grain of sand gets us near atoms. The quantum world is smaller still, home to the particles that make up atoms, electrons, protons, neutrons, and even more fundamental particles, quarks and photons, the building blocks of you, me, Earth, and the entire cosmos. Particles can act like waves, like a ripple in a pond. Until we measure, a particle has a wave of possibilities, a probabilistic world unlike falling apples or rolling balls. Another super cool idea is entanglement. What happens to one instantly correlates with the other, even across a room or a galaxy. These strange principles aren't just theories, they're tools. By learning to control them, we get quantum computers, unhackable communication, and ultra-sensitive sensors. The ultimate science experiment is happening right now. Okay, let's talk about our first incredible discovery, a massive leap forward in quantum computing. Classical bits are on or off. Quantum computers use qubits. Thanks to superposition, a qubit can be 0, 1, or both at the same time, like a spinning coin. That lets quantum computers explore huge numbers of possibilities simultaneously. For years, qubits were fragile. Vibrations, temperature shifts, tiny disturbances caused errors. Decoherence was like building a sandcastle in a windstorm. The big news: breakthroughs in quantum error correction, better shielding and systems that detect and fix errors on the fly. A game changer. Like giving our sandcastle a magical self-repairing shield. Enter logical qubits. Many physical qubits linked to act as one super-stable, error-corrected qubit. If one stumbles, the others keep it steady, much more reliable. This year, teams showed logical qubits far more stable than any single physical qubit, a huge milestone toward useful, large-scale machines. We're moving from small experiments to fault-tolerant quantum computers. Powerful and stable enough to run complex algorithms that could take classical supercomputers billions of years. The race to the first truly useful quantum computer is on and heating up. We won't carry quantum laptops soon. These machines will work behind the scenes, solving big challenges. Medicine and materials science. Simulating molecules is brutal for classical computers, but quantum speaks the same language. Imagine personalized drugs with precise, fewer side effects. Designing better batteries, more efficient, longer lasting, transforming EVs and renewable storage. Inventing catalysts to pull CO2 from air, helping fight climate change. Optimization for logistics and finance. Quantum can sift all possibilities fast, streamlining life, saving time, money, and energy. Quantum could accelerate AI training, enable sharper climate models, and scan massive telescope datasets for new planets. Quantum plus AI becomes a super brain for science, opening a new universe of discovery. Get ready for our second discovery, straight from the quantum realm's heart. Physicists are always hunting for new particles, beyond even the famous Higgs boson. Recently, a massive accelerator experiment found evidence for something wild: a sterile neutrino. Neutrinos are tiny, almost massless particles. Trillions pass through you every second, barely interacting. Ghosts of the universe. We knew 3 flavors, but anomalies hinted at a 4th. One that interacts only via gravity. That makes it even harder to detect than regular neutrinos. A true ghost. A highly sensitive underground detector shielded from cosmic rays was key. After years of data, a tiny but statistically significant anomaly appeared. The result could only be explained if a sterile neutrino joined the interaction. It was a eureka moment, while others confirm it's our strongest evidence for physics beyond today's model. The standard model is powerful, but incomplete. It can't explain dark matter. A sterile neutrino may be our first big crack toward a deeper theory. New particles reshape understanding and unlock new tech. We don't yet know the tech a sterile neutrino could enable, but history shows fundamental discoveries spark future innovations. Ultimately, it's about curiosity, understanding our world and our place in the universe. Each new particle is a message from the universe about its hidden structure. The sterile neutrino tells us profound secrets remain. The adventure is far from over. Keep looking, keep questioning, keep exploring the unknown. All right, for our third and final discovery, quantum teleportation. We're not beaming people. This is about teleporting information, the exact quantum state. First, create a pair of entangled particles. Keep A, send B far away, and prepare the particle you want to teleport, C, in the lab. Perform a special joint measurement on A and C. Instantly, B becomes an exact replica of what C was. The state teleports. In 2025, scientists teleported quantum information over several hundred kilometers using a new fiber optic network. Techniques strengthened entanglement and filtered noise, leaping past old limits. Quantum repeaters catch and pass along entanglement, extending range indefinitely. This is the missing piece for a global quantum internet. Quantum communication is inherently secure. Any eavesdropping disturbs the signal and triggers an instant alarm. That's revolutionary for governments, banks, and anyone protecting sensitive data. Online transactions, medical records, private messages, physically guaranteed privacy by nature's laws. This isn't a small improvement, it's a paradigm shift. A quantum internet can link many quantum computers into a distributed network, combining power across the globe. Researchers anywhere could run experiments securely on distant machines, accelerating discovery. Linking atomic clocks via entanglement turns Earth into a massive gravitational wave observatory. Quantum sensor networks could detect tiny environmental and geological shifts with unprecedented accuracy. Super powerful quantum computers, ghostly new particles, and real teleportation networks, we're in a golden age. The strange ideas of quantum physics are becoming practical tools. Like electricity's rise, today's quantum breakthroughs are early sparks of tomorrow's world. Next time you see your phone or a laser, get excited. Today's science is building tomorrow. Our quantum future is just beginning, and I can't wait to see what we discover next. It's going to be an amazing ride.